at the chain rule. Actually, let's not do that first. Let's look at the thing we already know first, because we already briefly talked about it last week or last lesson. So if I say y equals 4x cubed minus 2x squared plus 7x minus 4, and I want the gradient at -2, 4. Okay, so I've given you an equation and I've asked you to find the gradient at a particular point. So what did you say I have to do first, John? Let's differentiate dx dy. So we get what? 12x squared minus 4x plus 7. What do we do now? Substitute what for x? I just want you to be specific. Let's make sure we all know the x coordinate, right? So this is my x coordinate. So then 12 -2 squared minus 4 times -2 plus 7. So I get 12 times 4, which is 12 times 4, 48. Thank you. Jeez. What's this bit? Plus 8 plus 7. So altogether I get, thank you, 63 is the gradient at this point. That is stuff that they are like, hey, do you know how to do this thing? We already know how to do this thing. So now let's spend some time looking at the chain rule, which is something brand new we haven't done before, unless you're the boys down the back. All right, so we are going to, so far we have been differentiating things where there's one, I'm just going to give you an example of what I mean because I don't know how to explain that. So if I give you something like this, you know how to differentiate it. If I give you something like this, you don't. Okay, so when you have something that looks more like this, when there is a power over the entire section and it's more than one term, you can't just differentiate the way that we normally do. Okay, that takes so much more time. So we're not going to use the binomial expansion and then differentiate every single term because you get one question done per class. So what we're going to do is use something called the chain rule. So we're going to use something, some countries do a T, most countries do a U substitution. Our book is doing a U substitution, so we're going to do that. I think Addie was actually asking me this yesterday. The video I sent him does T's, but we're going to do U's. So another way I can write this is like that, where I'm going to call this whole thing here U. Then I can differentiate this. It's, I don't know, it's just a thing. And then later you use V's and stuff. Why me? Oh, okay. So we're going to do something. So when we talk about, so we've just talked about dy dx, right? When we talk about, dy dx, it's the differential of y in respect to the differential of x. Yeah, I know. All right, let's not worry too much about this. The chain rule tells us we need to do dy du. So we need to differentiate in respect to u, and then we have to multiply it by the differential of u and x. And I'll show you what that looks like. Honestly, it's much, much easier than I'm making it look right now. I just want to show you what that looks like. So if you see that, you know what it means. So I'm going to differentiate this. All right, so I'm going to just erase this. So I've got some space. What I'm going to do is I'm going to differentiate it just like normal. So I'm going to bring down the power. So dy dx in this case equals 4 times 3x squared plus 7x plus 10. And then I'm going to reduce the power by 1. Right? We know how to do that. That's not surprising. But now I have to multiply this whole thing by the derivative of just the bit inside the bracket. So now I get 6x plus 7, right? That's the differentiation of u. So this is the differentiation of this whole thing, right? This bit here, just the bracket bit as if it's a u, as if this is y equals u to the power of 4. That's what this bit is. Then this bit is the differential of u itself, right? Because we've called this bit u. No, you can just leave it like that. That's your answer, right? You don't need to use the binomial expansion and then expand it all. That is fine. You can expand it if you really want, but I don't think it's a great use of your time. All right, so can you get out your pen and paper? And I am going to give you an example now and see if you can follow that rule. So if I give you y equals 4x cubed minus 2x plus 6, and I'm going to make that all to the power of 3, can you try and use this rule and differentiate this for me? So differentiate the whole thing as if the bracket is just a u, then give me the differential, the derivative of the bracket itself. We'll see if we get it, and then we'll try it with something a bit harder. We could just leave it and do the easy bits. It gets bad when you've got like square roots and fractional powers. Come on, some of you aren't writing, you should be writing. Let's go. So following the purple rule or the purple pattern, see if you can do the green one.
We're going for dy over du, du over dx. Why is dy over du?
So the first thing you're doing is this, you are differentiating in respect to u. So normally we differentiate in respect to x, but we're substituting this whole thing for u.
Thing is being differentiated in terms of u, which is
right, a u substitution is what we call.
How do you know what u is?
Well, so we're just saying whatever the power is, everything that is to that power becomes u.
But what if you have a instance where you don't have that?
You won't.
You won't. That power.
Right. Okay, so hopefully we got that. 3 comes down the front. And then we reduce it by 1, so we get squared. Then the next bit is the differential of the bit in the bracket. So we should have 12x squared minus 2. Did we all get that? Yay. All right, now let's look at something where it's a bit more annoying because we have like fractions and powers and all sorts of fractional fun things. Okay, so what if I have y equals 3 root 2x squared plus 1? You would be very sad. Okay, what do we know about the square root? It's power of a half. So I'm going to rewrite this to the power of a half. Thank you. Okay, so what I'm going to do now is follow my chain rule. So I'm going to multiply the fraction by this. So now I have 3 on 2. And then I've still got this bit here. And then I'm going to subtract my power by 1. So it's the same thing, it's just more annoying because I've got fractions now. Now I also, because it's the chain rule, have to differentiate what's inside the brackets here. So I end up with 4x. Now I need to do something with it, right? Now I have negative fractions, which means what? Should be on the bottom. So this should look like that. Oops, actually what I'm going to do is put it back into this. And then I still have my 4x. Where does the 4x belong? Okay, you know what? I've written something really terrible here. Yep, it belongs on the top here. So actually, what this is saying is it's 12x, because the 4x times is the 3, 2 root 2x squared plus 1. So this is the derivative of this. You see what I'm doing? All right, let's have another go at that. What else do I want to give you? All right, let's have another go at that. I'm going to write one down. You're going to differentiate it. Y equals root 5 minus 2x. And actually, I'm going to put a 3 out the front just to annoy you. All right, let's do that. So I'm timesing 3 by negative half. Oh, what did I, no, by positive half. That's why I didn't do it. 3 is times half, which is 3 halves. Yeah. So you remember, you always take the power and multiply by the coefficient. All right, let's have a go at doing this one over here. Same thing. Differentiate. Use the chain rule. put it all back together. Okay, so hopefully you've rewritten it as your first step. All right, so my first thing I'm going to do is, again, multiply my power by my coefficient. So 3 halves, 5 minus 2x, subtract 1 from my power. And then this is the derivative of this, which is -2. I don't have any letters at all in it this time. So again, I'm going to rewrite this. Oh, I should have written dy dx, isn't it? This is the derivative. So dy dx is 3 over 2. Oh, let's not do it like that. Square root. Sorry. Yeah, good. So I'm going to bring this and put it on the top here. So what I have is actually -6 over 2 root 5 minus 2x. Is that my answer? I'm going to say this is incomplete. Why is it incomplete? No, it's not that it's negative. I can simplify it, right? What can I simplify it to? Yeah, good. So this is going to be -3 over square root 5 minus 2x, because I can divide these by 2. All right, that is my derivative of my original function. Okay, let's do one more where we start with fractions, because that's all the fun we want. I love you too. Okay, so what if I give you 5, so y equals 5 over 5x squared plus 3, well, let's write that better, 3 all to the power of 4. What should my first step be? Thank you, that's very helpful. What's the first thing I do when I find the derivative? What should I redo this as, maybe? Yeah, good. So let's first of all just rewrite this with a -4, right? Now it looks like something we can deal with. So anytime you have fractions, rewrite it with negative powers first, then you can derive it. So what's my derivative look like? Negative what? -20. I multiply this down here. So then I leave this as it is, and my power is -5 because I'm subtracting. And then what my chain rule says, what comes next? 10x, because that's the derivative of this bit. All right, let's try and rewrite this. So I've got -20 over 5x squared plus 3 all to the power of 5. And I have to multiply the whole thing by 10x. So what do I get? -200x all over 5x squared plus 3 to the power of 5. Can I do anything else? No, that's as simple as it gets. There's nothing that can be cancelled out. That's what I would have. All right, let's go for it. Let's practice the chain rule. We are doing 8.5.